Vector calculus, the very important one is integral theorems. Here, the first one is Green's theorem in the plane. Here, what is the statement of Green's theorem? If m of xy and n of xy be continuous function of the variable x and y, and having continuous partial derivative dou m by dou y and dou n by dou x in a region R. So here also we need the region of the xy plane bounded by a closed curve C. Then what is the statement is integral over C m dx plus n dy equal to double integral over R dou n by dou x minus dou m by dou y dx dy. Here C is the curve and it is traversed in the counterclockwise direction. Here the very important one is we are doing in the xy plane and bounded by a closed curve C. And this Green's theorem gives the relation between line and double integral. Now we do the problem under Green's theorem. So the first problem, verify the plane for integral over C where C is the closed curve. Already we said C should be closed curve of the region bounded by y equal to x and y equal to x square. So here we have to verify the Green's theorem of the given question. Here they are given C is the closed curve bounded by one straight line and one parabola. So how to start this problem means first we have to write the statement of the Green's theorem. By Green's theorem, what is the LHS? LHS is integral over C m dx plus n dy. It should be equal to double integral over R dou n by dou x minus dou m by dou y dx dy. We have to verify this LHS equal to RHS here. So here first we have to write what is our m, what is our n in the question. So m is nothing but coefficient of dx. Here m equal to xy plus y square. and n equal to x square. So as per our statement, what we need dou m by dou y. So dou m by dou y, we are doing partial differentiation with respect to y. So here x is the constant. So first one is x, y differentiation 1 plus y square differentiation 2y. Here dou n by dou x. So x square differentiation 2x. So first we are doing RHS. So what is our RHS? Double integral over R dou n by dou x minus dou m by dou y dx dy. So which is equal to double integral over R dou n by dou x is 2x minus dou m by dou y x plus 2y dx dy. So which is equal to double integral over R x minus 2y dx dy. So actually here what we need the limit. So then only we can do the integration. For that we have to draw the diagram. So here what is the region they have given? It is bounded by the straight line y equal to x. Y equal to x is this one. And parabola y equal to x square. Okay. So this is our region. So to find to evaluate the double integration, we need the limit. So I think you remember how to find the limit means we have to draw a line parallel to y-axis if we need y limit first. So here what is the value of y? Here it touches the parabola whose equation is y equal to x square. So the lower limit of y is x square. 2. Here what is the value of y? It touches the straight line y equal to x. So y varies from x to x square to x. What about the outer integration limit? Outer integration limit should be always constant. So here it is origin. Here this is the minimum value of the region. The maximum value is the point of intersection is 1, 1. So x varies from 0 to 1. When we solve this equation, we will get the point of intersection that is 1, 1. So 0 to 1. So this is the limit of our RHS. So our integration is equal to x varies from 0 to 1 and y varies from x square to x. And what is the function? X minus 2y. Here first we are doing with respect to y. So we have to write dy dx. If you are doing dx dy, that is also correct. Okay, that is our choice. First, we do integration with respect to y. So, treating the other variable. What is the other variable? X as a constant. So, write outer integration as it is. X integration xy minus y integration y square by 2. X square 2x dy. Now, we did the integration. Now, we have to apply the limits. 0 to 1. First, apply the upper limit. Okay, we have to apply the limit for y because we did the integration with respect to y. So, apply limit y equal to x means x square minus x square minus apply the lower limit that is x square. Here y equal to x square means x cube minus x to the power. Here substitute y equal to x square. X cube minus x to the power 4 dx. Here x square get cancelled. So what we get? 0 to 1 minus x cube plus x power 4 dx. Now we have to do the integration with respect to other variable x. So first term integration x cube integration x power 4 by 4 x power 4 integration x power 5 by 5. Here apply the limit. So minus 1 by 4 plus 1 by 5. Here when we take the LCM and simplify, we will get our 1 upon 20. This is our RHS. Okay, first we did RHS. So this is our RHS. Next, we have to do for the LHS. So what is the LHS? Integral over C m dx plus n dy. Okay, that is our given question is integral xy plus y square dx plus x square dy. See, LHS is nothing but the line integral. So here we have to check in our region how many lines are there. So what is the region here? This is the region. Here how many lines means we have to do in counterclockwise direction. So it is C1, this line, and it is going by this, it is C2. So it is bounded by two lines, C1 and C2. Okay. So we have to write integral over C1 plus C2. On C1. First we have to do for C1. So what is C1? C1 is y equal to, this is the C1. Here what is the equation? Y equal to x square. So y equal to x square. We have to change either y to x or x to y because we are doing the single line integration. Y equal to x square means dy is, we are doing differentiation 2x dx. We are converting y to x. So we need the limit of x. So in the region, here, this is our region. What is the limit means? A limit of x. Uh, Here it is going in this direction. So x varies from 0 to 1. Okay. X varies from 0 to, so integral over C1 equal to, okay, x varies from 0 to 1. In the place of y, we have to substitute x square. In the place of y, we have to substitute x square. So first term becomes x square plus y square. So here you substitute y equal to x square means x to the power 4 dx plus x square dy. Here also we have to substitute dy equal to, what is dy? 2x dx. So plus x square dy is 2x dx. Here we have to do the integration. So integration 0 to 1 x cube plus x power 4 plus 2x cube. So when we combine these two, we will get 3x cube. Integration is 3x power 4 by 4. Next, this x power 4 integration, x power 5 by 5. Limit is 0 to 1. So what we will get? 3 by 4 plus 1 by 5. So when we take LCM, what we will get? 19 by 20. This is for the line C1. Okay. Next, we have to do for the another line C2 because our region is bounded by two lines. So what is our C2 means this is C2. Okay, here the C2 equation is y equal to x. See here, this is going in this direction. So x varies from 1 to 0 and also y varies from 1 to 0. That is the important one because we are doing in counterclockwise direction. Okay. On C2, equation is y equal to x and dy equal to dx. And x varies from 1 to 0. Okay. So integral over C2, what is our function? Xy plus y square dx plus x square dy is equal to integral over, here we have to substitute y equal to x and dy equal to dx. So x into x plus x square dx plus x square dx. And the x limit is 1 to 0. Okay. So here what you will get in limit 1 to 0, 3x square dx. So when we integrating 3x cube by 3, the limit is 1 to 0. So which is equal to minus 1. Okay. So our RHS integral over C equal to what we said, integral over C1 plus C2. Integral over C1 is 19 by 20 minus 1. So which is equal to minus 1 by 20. So this is our LHS. Already we got our RHS also minus 1 by 20. So LHS equal to RHS. Okay. Hence, the Green's theorem is verified. We do the another problem using Green's theorem. Verify Green's theorem for so already we said we are doing Green's theorem for the xy plane. Here they have given the region is should be close to 1 and here they have given the region is a square. Okay. How to start this problem means first we have to write the statement of the Green's theorem. So what is the statement of Green's theorem? By Green's theorem, integral over C m dx plus n dy equal to double integral over r dou n by dou x minus dou m by dou y dx dy. Here what is m, what is n? First we have to write the given question. The m is coefficient of dx, that is x square plus 2xy, and n is y square plus x cube y. So here what we do, we have to find LHS, RHS separately and check whether they are equal or not. Definitely they should be equal only. First we can do LHS or RHS, that is our choice. Here first we are going to do RHS. RHS means the double integral, this part. Here what we need, this differentiation, dou m by dou y. So find dou m by dou y. What is dou m by dou y? Partial differentiation with respect to y. That is x square differentiation 0. Okay, here the differentiation is 2x. Dou n by dou x with respect to x. So y is constant. So y square is constant. So first term differentiation 0. Second term y is constant. So write y as it is. X cube differentiation 3x square. Okay. So double integral over r dou n by dou x minus dou m by dou y dx dy is equal to double integral over r dou n by dou x is 3x square y minus 2x dx dy. So this is the function to integrate for our RHS. But to find the RHS, we need the, okay, for that we have to draw the diagram. With the diagram only we can find the limit. Here what I have given, the given one is the region is square. Okay, in the xy plane, the points are 0, 0, 1, 0. Here it is 1, 1 and 0, 1. Okay, for the double integration, we need either y limit first or x limit first. If we want x limit first means draw a line parallel to x-axis in the region. So this is our region. In the region, draw a line parallel to x-axis. Here, what is the value of x means it touches the y equation, whose equation is x equal to 0. This is the starting point of the line. The end point of the line is this one, whose equation is x equal to 1. So x varies from 0 to 1. And for the outer integration, y. Okay. So here in this region, we have to write the minimum and maximum value of y. Here y varies from the lower value of y is 0 and the upper value is 1. So y varies from 0 to 1. So this integration is equal to x varies from 0 to 1 and y varies from 0 to 1. 3x square y minus 2x dx dy. Okay, it is a very simple one because the both lower and upper outer integral limits are constant only. First, we do the integration with respect to x. When we do integration with respect to x, keeping the other variable y as a constant. So write outer integration as it is. The first term, write the constant as it is. What are the constant? 3 is constant, y is constant. X square integration, x cube by 3 minus 2, x integration, x square by 2. And the limit is 0 to 1 dy. We have to apply the limits for x. Okay. So 3, 3 get cancelled. Here also 2, 2 get cancelled. So 0 to 1. When we apply the upper limit x equal to 1 means we will get y minus x equal to 1 means y minus 1. When we apply lower limit, both the terms are 0. So y minus 1 dy. So the inner integration is over. Now we go for the outer integration with respect to y. So 0 to 1. Y integration y square by 2 minus y. Y square by 2 minus y. The limit is 0 to 1. Okay. So apply the upper limit 1 by 2 minus 1. So which is equal to minus half. This is our RHS. Okay. Next, we have to do for the LHS. LHS is nothing but the line integral. Here the given question is integral over c x square plus 2x by dx plus y square plus x cube by dy. So here the line integral, single integral means we have to check how many lines are there in the our region. So here the region is, so what is the region they have given? They have given the region is nothing but the square. Okay. Here how many lines are there? Here totally we are having 4 lines. C1, we have to go in the counterclockwise. C1, C2, C3 and C4. So totally we are having 4 lines. So we have to divide our line integral into 4 lines. So which is equal to C1 plus C2 plus C3 plus C4. First, on C1. On C1, C1 is nothing but the x-axis. So here the x-axis, the equation is y equal to 0 and dy equal to 0. And x limit is varies from 0 to, okay. So here we have to put y equal to 0 and dy is 0. So integral over C1 is equal to, here y equal to 0 means what will happen? This term becomes 0. We will get x square dx. And dy is 0 means this whole term becomes 0. So we are getting only x square dx and the limit is 0 to 1. So when we do the integration, x cube by 3, 0 to 1. So which is equal to 1 by 3. Next, for the next line, C1. Okay, C2. C1 is completed. Next for C2. For the C2, the equation of the line C2 is, that is the line parallel to y-axis. That is x equal to 1. X equal to 1. Dx equal to differentiation of 1 is 0. And y limit we have to find. Because x is constant means y only, the other variable only varies. And the y varies from 0 to 1. So integration of C2 equal to, here x equal to 1, dx is 0 means this term becomes 0. So we have to put x equal to 1 here. Okay. X equal to 1 and dx is 0 means this whole term becomes 0. Here we put x equal to 1. So what we will get? Y square plus y dy. Y square plus y dy. And the limit is 0 to 1. So y square integration y cube by 3 plus y square by 2. When we apply the limit, we will get 1 by 3 plus 1 by 2, that is equal to 5 by 6. Next, third line. Okay, the third line equation is y equal to 1. See, they refer the diagram, our diagram, y equal to 1 and dy is 0. And x varies from, see the direction. Here the direction is x varies from 1 to 0. Okay, so that is very important one. Dy is 0. So dy equal to 0 means the second term fully, this term fully 0. This term. This term fully 0. And we have to put y equal to 1. Y equal to 1. So we will get x square plus 2x. So x square plus 2x dx, and see here the limit is from 1 to 0. Limit is x1 to 0, x square plus 2x dx. So when we apply the limit, apply the upper limit means 0, lower limit 1 by 3 plus 1. So which is equal to minus 4 upon 3. Then we go to the last line C4. C4 is nothing but the y-axis whose equation is x equal to 0 and dx equal to 0. Refer our diagram. Okay, and y limits also in this direction. Okay, in the direction of 1 to 0. That is the important. Usually don't write 0 to 1. It is the very important one. Y varies 1 to 0. So integral over C4 equal to y is 1 to 0, dx 0, x is 0 means we will get only y square dy. So when we do the integration, we will get like this, which is equal to minus 1 by. Now we have to add all these. Therefore, integral over C equal to integral over C1 plus C2 plus C3 plus C4. What is our C1? 1 by C1. How much we got? C1 is 1 by 3. And C2 is 5 by 6. And C3 minus 4 by 3. And C4 minus 1 by 3. So when we do the simplification, what is the final answer is? Already we did our RHS minus, so LHS equal to RHS. Hence the Green's theorem is verified. Okay. So in the Green's theorem, we have to check whether LHS equal to RH. Next problem, using Green's theorem, evaluate so they are given C is the boundary of the triangle, okay, in the XY plane with vertices 0, 0, 1, 0, 1, 1. See here what is the main difference in this problem is here they are asking using Green's theorem evaluate. Okay, so here we have to do the RHS part only. Okay. Here the LHS part, it is somewhat difficult to do. So by doing it, converting to the double integral by using Green's theorem, it is easier to solve the given integration. So first we write the statement of Green's theorem. By Green's theorem, what is the statement is integral over C m dx plus n dy is equal to double integral over R dou n by dou x minus dou m by dou y x. So in the given question, what is m? M equal to x square y and n equal to x square. So m equal to x square y and n equal to x square. As per our statement, we need the differentiation dou m by dou y. Dou m by dou y means x square is constant, y differentiation 1. And dou n by dou x, that is 2x. So double integral over R dou n by dou x minus dou m by dou y dx dy equal to double integral over R dou n by dou x is 2x minus x square dx dy. So here we need the limit. Okay. For that we need the diagram. So it is in xy plane. Here they have given it is a triangle. What is the vertices? 0, 0, 1, 0 and 1, 1. Okay. Here we need either the x limit first or we can find either the x limit first or we find the y limit first. Okay. If we need y limit first means draw a line parallel to y-axis in the region. So here this is the equation. What is the equation of this line? Y equal to 0. This equation is x equal to 1. And what is the equation of this one? It is y equal to x. So this is the starting point of the line. Here y value is 0. Here this is the end point of the line. Here the y value is x. So y varies from 0 to x. To find the outer integration limit, it should be always constant. We have to write minimum and maximum value of x. Here x value is 0 and x value is 1. Okay, starting value of x is 0 and maximum value is 1. So x varies from 0 to 1. So please recall the inner integration limit only as the variable. So this integration is equal to x varies from 0 to 1 and y varies from 0 to x, 2x minus x square. Here the order is dy dx because we found y limit first. First we do the integration with respect to y. Okay. So write outer integration as it is 2xy minus x square y. The limit is 0 to x dx. Okay. Now apply the limit. We have to apply the limit for the variable y. First apply the upper limit. Y equal to x means what you will get 0 to 1, 2x square minus x cube dx. Now we have to do the outer integration with respect to the variable x. Okay. So the first term is x square. The integration is x cube by 3. Second term x cube. The integration x power 4 by 4. The limit is 0 to 1. So when we apply the limit 2 by 3 minus 1 by 4. So which is equal to 5 by 12. So this is the way to solve the integration.